The last change that we will talk about for our sine and cosine functions is horizontal shift. We also call this a phase shift. A horizontal shift or a phase shift comes from adding or subtracting a value on the inside of our sine and cosine functions. As we go through this section, we will be doing the same steps that we've done before. We will find the x values first. We will take the inside of the function and set it between 0 and 2 pi and solve for x. Once we do that, we have the starting points and endpoints for that one period, and then we will find the midpoints by adding together the endpoints and dividing by 2. We will draw a dotted horizontal line that represents the middle of the graph, and now that vertical shift that we talked about determines the new middle of the graph. We will draw in the basic shape for sine and cosine, and we will use the amplitude to determine the vertical distance from the middle of the graph. Let's graph y equals sine of x minus 4, pi over 4, over one period interval. So our vertical shift, well, I haven't added or subtracted anything on the outside of the function, so there is no vertical shift. The amplitude, we have multiplied the front of the function by 1, so the amplitude is 1. The period, we have not multiplied x on the inside by any value. The coefficient of x is still 1, so the period will be 2 pi. So the only change that we've made is a phase shift. We have subtracted pi over 4 on the inside of the function. Phase shifts always occur in the opposite direction of the sign that we see. So if we see a minus pi over 4, if we see a value subtracted from x on the inside, then the phase shift will actually go toward the right. So our phase shift will be a positive pi over 4. To see where we start and where we end, we are going to set the input of the function once again between 0 and 2 pi. So now the inside or the input of our function is x minus pi over 4. Now we need to be careful here. In order to get x by itself, we do need to add pi over 4 to all three parts. And the reason why you want to be careful here is because we have to have a common denominator before we can add fractions. So we're going to think about this as 2 over 1. And our common denominator we see would be 4. So that would actually be 8 pi over 4 plus pi over 4. So our starting value, 0 plus pi over 4, starting value would be pi over 4, less than or equal to, our pi over 4's cancel out, so I'll have x in the middle, less than or equal to, and that would be 9 pi over 4. So the starting point and the ending point are now going to look very different than they did before. So our whole entire graph is now being shifted over to the right. The starting place is now at pi over 4, and the ending is now at 9 pi over 4. Now we're going to add these values together and divide by 2 or multiply by 1/2, same thing. We're going to add the values together and then we're going to half it. So what is pi over 4 plus 9 pi over 4? Well, that would give 10 pi over 4. And then we have to multiply by 1/2, so we want to half that. We want to simplify all of this, reduce common factors. So we see that 10 and 4 have a common factor of 2. 10 and 2 have a common factor of 2. And if I multiply across now, we get a midpoint value of 5 pi over 4. Now let's find this quarter point here. Pi over 4 plus 5 pi over 4. Well, that would be 6 pi over 4. Be really careful, don't stop there. We also have to divide it by 2 or half that, multiply it by 1/2. We want to reduce. 2 and 6 have a common factor of 2. So that gives us, if I multiply across, 3 pi over 4. So we want to reduce that fraction. Now the last midpoint, we're going to take 5 pi over 4 and add that to 9 pi over 4. So we're going to add together. That gives 14 pi over 4. But we need to half that, so we're going to multiply by 1/2. reduce common factors, so 2 and 14 have a common factor of 2, so that gives 7 pi over 4 as the reduced midpoint. So we add together, multiply by a half, or divide by 2, same thing. So now we have all of our midpoints, and we want to graph the sine wave through these 5 points. So let's draw in our y-axis, and pi over 4, all of these values are positive, so the y-axis would have to be to the left of them, and the amplitude is 1. So let's draw in our 1's for our amplitude. So 1 and negative 1. Let's come down a little bit and actually make this a little bit lower. So positive 1, negative 1. So our sine wave is going to look exactly the same, except it has to start here at pi over 4. So sine starts at the middle of the graph, goes up to the max at the second point, and this is now my second point. At the third point, it comes back down to the middle, to our x-axis at this point, goes down to the minimum of negative 1 at the fourth point, and then at the fifth point comes back up to the middle of the graph. So we see that our sine function has shifted to the right pi over 4 units.